This is an audio guide for these notes. All I will be doing is reading things off of the slide. This is more for my people who like to hear things. This helps them fill out their notes a little bit better. If you don't want to listen to this, you don't have to. You can take the notes off the rest of the slideshow without listening to this, especially if you just don't want to hear my voice that long. All right. This is the front. This is the back. You are listening for a couple words. You're listening for region. There's 3 regions. You're looking for main purpose. Each region has a main purpose. You're looking for the parts in each region. You're looking for what happens here. What happens here. As you go, you can also pause the video and do the diagram on the back. You can stop at any time and label these things. You may not be able to label everything, but we'll see how well we do. We'll go over it together in class. The human ear. The ear can receive sound waves as vibrations and convert them to signals that are processed by the brain. The ear can receive sound wave as vibrations and change them into signals that the brain can understand. The 3 main regions we're going to look at: the outer ear, the middle ear, the inner ear. These are the 3 main regions. The first main region is the outer ear. Its purpose is to collect sound. There are 2 parts: the pinna, which is the outer flappy part. It's the part you can see. And the ear canal, which goes into the ear. The pinna is this outside part. The external ear canal is the part you could maybe stick your finger in, but then the ear canal keeps going back. Here's how it works. The pinna collects sound waves and funnels them into the ear canal. The pinna collects sound waves and funnels them down into the ear canal. The second region is the middle ear. Its job is to transmit sound. The middle ear's purpose is to transmit sound, to move sound from one place to another. There's 4 parts: the eardrum, the hammer, the anvil, the stirrup. The eardrum, the hammer, the anvil, the stirrup. Those 3 are 3 tiny bones that are all connected. Sometimes you see them listed all together. So here's how it works. The pinna collects sound and funnels it to the ear canal. The sound waves make the eardrum vibrate. This video on the slideshow will show you what a real eardrum looks like if you will go to a doctor's office and they look at your eardrum. So vibrations make the eardrum vibrate, and the middle ear will transmit those vibrations. Here's the next step in how it works. The eardrum causes 3 little bones to vibrate. These bones act as a medium to transmit vibrations further into the ear. These bones act as a medium to transmit vibrations further into the ear. Another view of the hammer, the anvil, and the stirrup, the 3 bones, and the eardrum. Sometimes they show their Latin name. The hammer sometimes gets called malleus. Anvil sometimes gets called incus. Stirrup sometimes gets called stapes, but it means the same thing. They are very, very small. The main purpose of the inner ear, the last region is the inner ear, and its purpose is to translate sound, to change it. The third region has two parts. The inner ear has the cochlea, and the auditory nerve. Auditory nerve. This is what a cochlea looks like in an animation that I found. And here's how it works. The outer ear collects and amplifies sound waves. The sound waves make the eardrum vibrate. The eardrum causes three little bones to vibrate. The stirrup, the last bone, vibrates against the cochlea, which is filled with liquid. Vibrates against the cochlea, which is filled with liquid. And this causes tiny hair cells to vibrate inside the cochlea. This causes tiny hair cells to vibrate inside the cochlea. Your cochlea is very small. It's smaller than the fingernail on your pinky finger. So if you hold up your pinky finger, you can see how small your cochlea is. Over time, your hearing may become damaged. This could be due to a lot of things, including aging or getting older, injury, getting hurt, excessive noise exposure. That just means you're around noises that are too loud for too long. And finally, viral infections. Certain infections, if they get bad enough, could damage your hearing. Normal cochlea cells might look like this from above. Damaged cochlea cells might look like this. Remember how older people have a harder time hearing high frequency sounds? Well, this is why. The hair cells detecting higher frequency sounds are getting the most damage because they are where the sound waves hit first. These cells detect higher frequencies, and these detect lower frequencies. They get hit first by the sound wave, so they get worn out faster. The last part of how it works, we know all of this. The last part is the cochlea sends electrical signals to the auditory nerve and then sends those signals to the brain. The cochlea sends electrical signals to the auditory nerve and onto the brain. The cochlea, the auditory nerve fiber, and it goes up into the brain. The auditory nerve is right here. It's part of the inner ear. And the cochlea converts the sound waves into signals that get sent into the brain to the side part of the brain right here. And the brain will interpret the sound. This auditory cortex in the temporal lobe, this spot tells you all about sound and what you're hearing. On the side of the brain, you see right there, that's the part of your brain that understands sound, the auditory areas. There are a bunch of videos on how the ear works that you could watch. 2 of them are on YouTube. 2 of them are on Discovery Education, and you have to log into Discovery Education before you click these links. You can check your work as well, make